Okay, so we're going to talk about some general properties of a gas. Gases are thought of as a fluid because they flow. They take up the size and the shape of their container, and they are easily compressed. When they're not normally in a gaseous state, say water, for example, is usually a liquid. If you put enough energy into water, you can create water vapor, or you can create vapors of other solids even that are normally not in the gaseous state, but if you put enough energy in, you can vaporize them. So if they're not at room temperature, a gas, when they're turned into a gas, they're known as a vapor. There are little to no intermolecular forces between the molecules of a gas. And so we say that the gases don't stick together. They have totally elastic collisions. They act as independent operators. And because of this, under normal conditions, temperature and pressure are things that most affect the gas properties. Okay, so now let's talk about some ideal gas laws. So ideal gases are most predictive when the conditions are moderate. The temperatures are not too high or low, and the pressure is not extremely great. So what happens is that under normal conditions, these gas molecules are free to move and they don't interact with each other a whole lot. When they collide, they bounce off each other and no energy is lost. But if you compress a gas and cool it off, the molecules move extremely slow and they're closer together because you're compressing it, and they stick together. They're a little bit sticky, and so they are not as easily predictable in terms of their properties. But under normal conditions, these gases follow. So here again, collisions between the particles are said to be elastic, meaning no energy is lost. The distance between the particles is great compared to the size of the particles under these conditions. Alright, and so the size of the gas molecules are so very small compared to the distance. Even if you have a mixture of large and small gas particles, they behave pretty much the same, and you don't have to take into account the size of the molecules when you're working the problems.